Today we're going to be talking about the uniform distribution. So the uniform distribution is denoted in this way, right here. And that's equivalent to telling you, if you're told it's uniform, that means that the density function of f of x has the form on the right of 1 over b minus a when x is between a and b, otherwise it's 0. So those two facts are interchangeable. So this formula for f of x and being told it's uniform, those two are interchangeable. Okay. So here we've applied a is 0, b is 4, and the density function here is 1/4. We know the total probability of f of x is 1, so intuitively, if we're asked to calculate the probability that x is bigger than 2, well, that corresponds to this probability. Okay, so 2 corresponds to all the probability here, okay, in red. So it'll be this integral from 2 to 4 of 1/4 dx, okay? And intuitively, since that's half, and this is a constant function, half of the total probability, we believe this should be 1/2 of the probability. So automatically, we already know this calculation is 1/2, but um, we're going to verify it by calculating the integral. So this is going to be 1/4 x between 4 and 2. This becomes 4 over 4 minus 2 over 4, and indeed this is 1/2. Okay, so that is the amount of probability um, that we get, and it matches our intuitive correspondence or intuition. Okay, if we're asked to calculate the probability that x is less than 2 and greater than 2 and less than 3, well, that's about 1/4 of the total probability, but let's verify that with this integral. And excuse me, the limit of integration here should be from 2 to 3. Okay, so indeed that is 1/4. So what is this trying to tell us? It's trying to tell us these rules. The first is if we're asked to calculate the probability that x is between a and b, this is given by the integral between a and b of f of x dx. That's the main rule that I want to communicate to you, is this one right here, number 1. Number 2 is if you're told you want to calculate the probability x is greater than a, this is this integral from a to infinity of f of x dx. And the last one is if you want to calculate the probability um, that x is less than or equal to a, um, this is actually called the cumulative, because you calculate all the probability up to a, and this is equal to f of a. This thing is called the cumulative. Okay? And its definition is it's the probability x is less than or equal to a, and this is going to be the integral from minus infinity 2a of f of x dx. Okay, so um, the main thing I wanted to communicate were these three rules, and then one more. Okay, so for example, let's calculate the cumulative of f of x, where f of x is this 1/4 and it's 0 for all other values. Okay, so f of x here is going to be the probability big X is less than or equal to little x, and this is the integral from minus infinity to x of, I'll call it f of t dt. But notice the density function is only non-zero starting at 0. So this will be the integral from 0 to x of 1/4, and I'll do dt. Okay, I changed it to dt so that it doesn't match the x in the numerator there, and that was a little bit important. And this will be t over 4 evaluated at 0 and x. This will be x over 4. Okay, and one important relationship is that if I was to derive this, the derivative of the cumulative is 1/4, and that's f of x, the density. So there's a relationship between the cumulative and the density. And it's as follows. So the relationship is just that f prime of x is equal to f of x, the density. And this is proven directly using the fundamental theorem of calculus. You can think of this as your fourth rule. Okay, thank you very much.